Staying alive, staying alive. Ah, 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 staying alive. Ooh. Could you picture me dancing to that disco? Now, I don't recall why when I made this presentation, I made the background a disco scene. But anyways, there's some good dancing music from the disco times back in the 70s and 80s. Well, anyway, we are going to talk about midpoint and distance in this video. Two things that deal with lines in general and dealing with uh, well, when you're measuring things, particularly on a coordinate plane. So our two goals or learning targets for today. I'm going to draw my little target for my learning target. One would be to find the midpoint of a line segment. And the midpoint is actually what it sounds. It's the middle point between, of the segment. And then the second one is to find the distance between 2 points on a coordinate plane. And believe it or not, there are formulas that will help you do each of these things. And that's what we're going to get to mainly today. All right, so we're going to skip this, and we're going to go straight to midpoint. I don't have a definition, but midpoint really is, well, here it is. On a number line, there's two different ones. It's the coordinate is the average or the mean of the coordinates of the endpoints. So when you have just a number line, one number line, like we have right here, we have point A, we have point B. We're trying to find what's exactly in the middle. So midpoint really equals the middle point. Hence why it's named the midpoint. So to find the midpoint, we're really just finding the average. And you can count back from both sides, or you can take the average. So you have whatever A is, add that to B, and divide it by 2, so it's finding the average, and you get the midpoint. Now on a coordinate plane, it's slightly different. You're finding the average of two things. Because on a coordinate plane, we actually have coordinates, so we want to find a coordinate. So there's going to be, for the x value, if it's between two coordinates, so it says the coordinates of the midpoint are the average of the x coordinates and the average of the y coordinates. So when we have 2 points, like we have here, we have point A and point B. You realize each point has an x and a y. So to find the x value of this midpoint, we do the average of it. We do the average. So we have the first x plus the second x, divide that by 2. And then to find the y value, do the same thing, only we do the average of the y. So we take the first y plus the second y, and divide that by 2. And then you get the average of both the x and the y, which will be our midpoint. So let's do an example of that of each of those. All right. First of all, let's start with a coordinate plane. No, sorry, not a coordinate plane. Just a number line. We have g is -6. So that's our first point. So we're going to do -6. Midpoint is going to be equal to -6 plus the other point is 4. We want to divide that by 2. So -6 plus 4 is -2. And that's going to be equal to -1. So our midpoint is going to be -1. And you can see just a visual, it's right between those two. From here to here, from here to here are exactly the same length. I believe it's 1, 2, 3, 4, 5. All right? So that's midpoint on a number line. Now, number 2 says EF has endpoints 7, 5, and 2, -4. What are the coordinates of the midpoint? You don't even really need the graph. We can estimate it's going to be somewhere like around here or something, but that looks like it's in the middle. So we're going to have to use this formula. So let's go. This is our x1 and y1. And this is our x2 and y2. So to find the midpoint here, we're going to find the average of the x's and the average of the y's, which is what we were told to do right up there. So the two x's added together are 7 plus 2, divide that by 2. And then the y's are 5 plus -4, divide that by 2. So 7 plus 2 is 9, divided by 2, you get 4.5. And then 5 plus a negative 4 is going to be 1. So we actually get 1 over 2, which is 1 half, or 0.5, since we're dealing with decimals. So I guess we averaged correctly, 4.5 and up 1 half. So that was correct. It was a good estimate right there. So that's how you use the midpoint formulas. Couple questions here. 3, it says find the coordinates of the midpoint for T and R. Now you don't have to have a graph, like I said. We just plug in the x's. We have negative 1 plus 4 divided by 2. And then the y's would be 6 plus 9 divided by 2. And you end up getting, I believe it's 1.5 and 7.5 for your midpoint. Alright, I've got 2 more. So for 4 and 5, it says here you know the midpoint and you want to find one of the endpoints. So to visualize it, if we have this line right here, well, if we have this segment right here, we know that the midpoint's here. We know this one, but we do not know the other endpoint, so we have to try and figure it out. Now, there's a couple ways to do it, and I find that the best way is just to stick with the formula. So if we're dealing with the x value, think about it. For number 4, the midpoint is 3 and negative 6, so the x has to be 3. So let's just deal with the x first. The x value has to be 3. We know that's the midpoint. To find the midpoint, you find the average of the other two. So let's just do our x1. We don't know that. And we know the other one is 1 divided by 2. Now it's just like we're solving an equation. Multiply both sides by 2 to cancel this out. You get x plus 1 equals 6. And then you subtract 1 from both sides. The x is going to be equal to 5. Okay? Now, for the y's, we do the same thing, only with the y value. We're still using that average, because we don't know one of the y's, so we're going to do y plus the one we know is negative 2, divided by 2, and that's going to end up getting negative 6, because that's what our y value for our midpoint is. So again, solve it just the same way. Multiply both sides by 2. You get y plus negative 2 equals, oops. So that is then equal to negative 12. And then when you add 2 to both sides, because we want to undo this negative 2, you get y is equal to negative 10. So the original point that we were looking for was 5 and negative 10. And to check that, you can plug it back in and try it the other way if you'd like. Alright, so I'm going to leave this one for you. I'll come back and show you the answer in a little bit. But it says the midpoint of FE is G, which is 2, negative 5. What are the coordinates of F if we know E is negative 4, negative 3? Alright, now let's do a brief overview of the distance formula. The distance formula is referring to how you find the distance between any 2 points in a coordinate plane, specifically if they're not vertical or horizontal. Because if we're dealing with vertical lines, we could just count, or horizontal, we could just count. But if they're diagonal, we can't count because they're not, I mean, we don't have a diagonal axis. This goes counting 1, 2, 3. So we gotta have a way to do it. And really, this is based off of the Pythagorean theorem, where you're finding the third side of a triangle. We're not going to go into detail on that right now, but this is the formula. Okay? So the distance between 2 points is this. The square root of the second x minus the first x squared plus the second y minus the first y squared. So really you're finding the difference between the x's and squaring it, the difference between the y's and squaring it, adding those two together and taking the square root. So just so that you have a better understanding of how that even makes any sense, I'll show you how it works. So example number 1, find the distance between each pair of points, round to the nearest tenth if necessary. So we have the first x, so this is x1, x2 is over here, y1, y2, just like always. And we're simply going to just plug into the formula. So the distance between those 2 points is the square root of the x2 is 6 minus the x1 is just 1. And that's squared. Plus the y2 is negative 3 minus 2. And that is squared. And simplifying, we have the square root of 5 squared plus negative 5 squared, which would be the square root of 25 plus 25, which I'm going to go over here, which is the square root of 50. And if you take the square root of 50, just use a calculator right now, you can estimate, certainly you can estimate, it's going to be just over 7, because the square root of 49 would be 7. So the square root of 50, so about, you'd round it to the nearest tenth, 7.1. Alright? So the distance between those 2 points is just over 7 units. Alright, so why don't you try number 2 on your own, and I'll come back and show you the answer for number 2. Alright, a little bit of an application here. Oftentimes grids are used for things like this, for different maps. Grids are certainly used, something that I learned, underwater archaeologists who go underwater and find things that have been left underwater, or uncover things that have been underwater. They use grids because, I mean, if you're just out on the water, it looks exactly all the same. So according to the radar, you got to know how to read a grid, and they can find distances between places like by using the distance formula. Now, at number 3, it says, on a zip line course, you are harnessed to a cable that travels through the treetops. You start at platform A and zip to the other platforms. How far do you travel from platform B to C? And then number 4 says, how far do you travel from D to E? Um, just trying one of those would be good practice. I'll just help you set up. Let's do one more here. It does say that they're all 5 apart. So this C is negative 15 and 10. That's C. And then D is negative 30, negative 20. So again, just remember that what the distance formula is the square root of the second x, which is negative 30 in this case, minus x1, which actually is negative 15. Those are going to cancel out. Plus y2, which is negative 20, minus y1 squared. And then you simplify it from there. Do the same thing with from D to E. Alright, so just using the distance formula there. So finally, I have two error analysis problems for you. Finding the error. Number 1 says, what are the coordinates of point B if the midpoint is 2, 1, and the coordinate for A is that? So kind of like one of those problems we did before, there where to find the missing coordinate when you have the midpoint and the other coordinate. Find the error in that work. And then number 2, we're using the distance formula. Find the error in that work. Okay, and I'll go back and show you now those 2 problems. We have the midpoint one. I think I left one of those for you. The last midpoint one. So you can pause it and look at the work if you want, but you end up getting 8 and negative 7. And then the distance formula one, I end up getting 3. This one would be easy to just look at a graph because it makes a vertical line. Alright, then why don't you go back to the original goals, to find midpoint of a line segment and to find the distance between 2 points on a coordinate plane. Can you do those? Do you have questions on those? Those are the things that I want you to think about and bring next time. Alright, so that is the section on midpoints and distance formula. Have a great day.